So in our mom and pop cafe, uh, so these are the benefits of cloud computing for our cafe. And if we talk about the challenges, difficulty in replication across region, it's like trying to open new branches of the cafe in different countries. Manually setting up everything in each location takes a lot of time and can lead to mistakes, making it hard to provide a consistent experience for customers worldwide. Secondly, lack of separate development and production environments. Maintaining separate development and production environments with matching configurations is difficult. Manual setup makes it hard to reliably replicate configurations across environments, leading to inconsistencies and potential issues. Then thirdly, complexity of managing diverse architectures. Cafe has many different architectures, making it challenging to manage and update them consistently. Manual management becomes unsustainable as the complexity of architectures increase. Risk of manual implementations, risks in terms of reliability and security. And lastly, lack of scalability and version control. So, manual creation of resources and architectures does not scale effectively. There's no inherent version control, making it challenging to maintain audit trails and ensure compliance with security standards. Now, if we talk about what is Elastic Beanstalk, Elastic Beanstalk is like having our own team of cloud experts working for us behind the scenes. It's a service provided by AWS that takes care of heavy lifting involved in deploying, managing, and scaling web applications. With Elastic Beanstalk, we don't need to worry about the nitty-gritty details of setting up servers, configuring databases, or installing software. Once our application is up and running, Elastic Beanstalk continues to manage it for us. This means handling tasks like software updates, patching security vulnerabilities, and keeping everything running smoothly. One of the most powerful features of Elastic Beanstalk is its ability to automatically scale our application based on demand. So if our website suddenly gets a surge in traffic, Elastic Beanstalk will automatically add more resources to handle the load, ensuring a smooth experience for our users. Elastic Beanstalk also comes with built-in monitoring capabilities. This means we can easily keep a track of key metrics like CPU usage, memory usage, and request latency, all from a single dashboard. So, what does all of this mean for mom and pop cafe? In a nutshell, Elastic Beanstalk makes it incredibly easy to deploy, manage, and scale their online services without needing a team of experts or investing a lot of time and resources. And what is cloud formation? So, it's a powerful service for managing cloud infrastructure, allowing users to define their desired resources and configurations using a declarative template format. So users describe their infrastructure requirements in a template file using a simple human readable format. This template serves as a blueprint for provisioning and configuring AWS resources. Automated infrastructure provisioning, this eliminates the need for manual setup and configuration, saving time and effort. Consistency across deployments, each deployment follows the same predefined configuration, reducing the risk of human errors and inconsistencies. Version control, it can roll back to previous versions if needed. This ensures transparency and accountability in the deployment process. And users can quickly spin up new environments, make changes, and replicate configurations with minimal efforts, thus ensuring simplified infrastructure management. Now, if we talk about comparison with traditional deployment strategies, there's manual versus automated deployment. So, traditional deployment involves manual provisioning and configuration of hardware and software components. That is not the case with Elastic Beanstalk and CloudFormation because they automate the deployment process. And with manual deployment, we have it requires significant time and cost, while Beanstalk and CloudFormation automate provisioning and scaling and manages tasks, so it reduces the time and cost to a larger extent. Uh, Thirdly, reduced risk of human error. So manual deployment is prone to human errors. And there's stacks and resources in cloud formation. So we organize resources into stacks. Stacks enable us to create, update, delete all the related resources together, simplifying management and ensuring consistency. And auto scaling and load balancing, this dynamic scaling and load balancing ensures optimal performance, high availability, and cost efficiency. Uh, If we talk about the benefits of Beanstalk and cloud formation, in Beanstalk, there's simplified deployment. So it makes it easy for cafe to launch their online services without needing to understand the technical details. It's like using a pre-made recipe instead of figuring out how to cook from scratch. It saves time and effort. Second, automatic scaling. So Beanstalk adjusts the resources their online services need based on how many people are using them. It's like automatically adding more staff when there's a rush of customers. It ensures everyone gets served quickly without cafe needing to do anything. Built-in monitoring. Again, Beanstalk keeps an eye on how their online services are performing, like tracking how many people are visiting their website or using their app. We also have support for multiple platforms like Node.js, Java, etc. And there is cost efficiency and built-in load balancing. Benefits of cloud formation. So streamline infrastructure management. It helps cafe manage all the pieces of their online setup from one place without needing to understand all the technical details. Version control and replication. It lets cafe keep track of the different versions of their online setup, like saving different drafts of a document. Cost efficiency. It helps cafe use only the resources they need for their online services, and also easy cleanup and rapid deployment of complex environments. If we talk about the integration, both Elastic Beanstalk and CloudFormation work together to make it as easy as possible for the cafe to run their online business smoothly without needing to worry about the technical side of things. It's like having a reliable partner who takes care of everything behind the scenes so they can focus on serving their customers and growing their business. So, in integration, we have dynamic scaling, management and updates, and stack creation. When we facilitate capacity provisioning, load balancing, and monitoring in our cafe, what we do is we automate capacity provisioning using CloudFormation. There is already built-in load balancing, as mentioned earlier in Beanstalk, and we can monitor and do health checks. That will be discussed now, which gets back to monitoring deployed resources. So, environment health monitoring, it accesses health of instances, load balancers, and other resources, providing insights into their status and performance. The metrics, instance metrics, Beanstalk collects and publishes metrics such as CPU utilization, memory usage, disk space, network traffic for each instance in the environment. Application logs, Beanstalk integrates with AWS CloudWatch logs, allowing us to view and analyze application logs in real time. We can troubleshoot issues and monitor application behavior. And lastly, customer metrics and alarms. With Elastic Beanstalk, we can configure custom metrics and alarms using AWS CloudWatch. In CloudFormation, we have resource level monitoring. So it provides monitoring at a resource level, allowing us to track the status and performance of resources created using CloudFormation templates. We can monitor metrics such as creation time, updation time, resource dependencies. Stack events, it generates stack events that provides insights into the status of stack operations such as stack creation, update, and deletion. We can view stack events in the AWS Management Console or programmatically access them via the APIs. And drift detection. So in drift detection, it offers the drift detection, which helps identify any differences between the deployed stack and the template used to create it. We can detect drifts in resource configurations and take corrective actions to ensure stack consistency. Then we have monitoring tools, both integrate with AWS CloudWatch, a monitoring and observability service, both in the sense Beanstalk and even the CloudFormation. Now let's talk about the architecture of our cafe, mom and pop cafe. So we have our internal consumers and external consumers. They are using mobile apps and websites for ordering There is this API gateway, Amazon API gateway, that acts as a gateway for all the services within the AWS ecosystems. Then we have EC2 instances. This is our elastic beanstalk that can launch multiple EC2 instances, and it includes load balancing and an automatic scaling configuration. Then there is a machine learning ecosystem which gets data from Amazon's serverless DB, DynamoDB, which is the data store for the cafe store. And the data is exposed using lambdas. So if we compare this to a traditional architecture where the web application is always running, so this architecture is not always going to run. When some user sends a request to the API gateway, it triggers the Lambda dynamically, and then it is going to consume data from the data store. So Lambda is by default scalable. When we configure the Lambda, we can define how much scale it can withstand to. So it can automatically scale up and down based on the configuration. And coming to the backend part, how the data is ingested into the DB, there are incoming messages onto the SQS queue, which is serverless, that gets consumed by the Lambda, which is which again pushes the data into the DynamoDB. DynamoDB will only be changed for data, like we will only get charged for data retrieval and transaction cost, the read and write cost. The users will send notifications via the email notifications component of AWS. Now, if we observe here, we also have cloud formation templates. So this is a more detailed picture architecture of our cloud formation. So AWS cloud formation templates, it has we have templates for Cafe network stack, Cafe application stack, even for S3 stack. And it's for the both the regions, region 1, region 2, having EC2 instances, security groups, VPCs, and internet gateways. So if we talk about the cost and potential savings now, it follows a pay-as-you-go pricing model. So both follow a pay-as-you-go pricing model, meaning Cafe would only pay for the AWS resources they use without any upfront cost or long-term commitments. This aligns with their business needs, allowing them to scale resources up and down based on demand. Optimized resource utilization, both CloudFormation and Beanstalk help optimize resource utilization by provisioning only the necessary resources needed for the cafe's online services. This prevents over provisioning and ensures efficient use of resources, reducing unnecessary costs. Then reduced operational overhead by automating infrastructure, provisioning, and management tasks. Both services reduce operational overhead for the cafe. And lastly, cost transparency and control. Both of them provide cost transparency and control, allowing cafe to monitor their AWS spending and adjust resources as needed. They can track usage patterns, identify cost drivers, and make informed decisions to optimize costs further. So, in conclusion, we can say that mom and pop cafe can maximize the benefits by using the uh, cloud infrastructure like automation, standardization, and consistency, continuous improvement, and cost savings. Thank you.